Question 8. It is given that fx equals to 5e to the power of x minus 1 for x is the element of all real numbers. Part 1. Write down the range of f. For this kind of question, you have to know how the graph looks like. So an exponential graph will usually look something like this, or maybe like this. So for this graph, it will look something like this. So as you can see, there is no ending to the y-axis, and since it's asking for the range, which is the y part of the graph, and since the y-intercept should be minus 1, the range is f is bigger than minus 1. Part 2. Find the inverse of f and state its domain. The inverse of f can also be written as f minus 1. And to start off this question, you first write the original equation. And then from here, you make fx equals to y, so that it is easier for you to move around the numbers. And then from here, you just make x the subject. So you move the 1 over, and then if I just simplify this, it becomes this. And when you move the 5 over, it becomes y plus 1 divided by 5. And to make x the subject, we have to use the log to the power of e, y plus 1 divided by 5. Or you can also write this as ln y plus 1 to the power of 5, as ln, or also known as ln, can also mean log to the base of e. So the domain of a inverse would be the range of the original. So the domain of this graph would be x is bigger than minus 1, as the domain of the inverse of a graph is the range of the original graph. Anyways, this is the domain, and now the inverse of f is equals to ln x plus 1 divided by 5. How do you do this is, if you look here, you get x equals to ln y plus 1 divided by 5. And from here, you just switch the y to the x, so that you get the inverse of f equals to ln x plus 1 divided by 5. It is given also that gx equals to x squared plus 4 for when x is an element of all real numbers. Part 3. Find the value of fg bracket 1 bracket. So to do this kind of questions, this literally means f g1 bracket bracket, which can also mean f, and then when there's a bracket inside of the function and not the x, it means that the number inside the bracket is replacing the x, so it's substituting for the x. So g bracket 1 bracket would also mean 1 square plus 4, as you just substitute the 1 inside the x, so you get 1 square plus 4, so 1 square is 1, so 4 plus 1 is 5. And then f bracket 5 bracket can also mean 5e to the power of 5 minus 1, as fx equals to 5e to the power of x minus 1. So you are just replacing the x with the number. And then you can either put your answer as this, or you can just put an estimate, as it didn't specify if you have to give an exact value or not. So from here you can just do 5 to the power of e, 5e to the power of 5 minus 1. And then here you can just put the answer as 3 significant figures. So it will be 741. And that will be your answer. Part 4. Find the exact solutions of g squared x equals to 40. So first of all, gx equals to x squared plus 4. So basically g squared x is g bracket x. So it's like the function is inside the function. So does that make sense? So g squared x does not mean, for example, it does not mean x squared plus 4 squared. It does not mean that. It means that g x squared plus 4. So you're substituting the equation inside the original equation. So basically this here will become x squared plus 4 squared plus 4. Because you're substituting x squared plus 4 literally inside the x value of the original function, which is gx. So this is your g squared x. And then from here, you can just simplify this. So it becomes x to the power of 4 plus 8x squared plus 16 plus 4, which is equals to 40, as it is in the question. So this becomes x to the power of 4 plus 8x squared plus 20 equals to 40. So after you get this equation, you have to move the 40 over. And then if you simplify this, it becomes minus 20. And then from here, you can just factorize these two equations. So to do that, you may get confused as the power of this x is the power of 4. Well, you can change that by saying let x squared equals to a variable or a letter that you want, like for example a, so that this becomes a squared plus 8a minus 20. And as you can see, this becomes a quadratic equation, or you can simplify it by using the quadratic formula, which is a equals to minus b plus minus square root of b squared minus 4 times 1 times c, which is minus 20, and then it's 2 times 1. So and then if you simplify this, it becomes like that. So it's 64 plus 80 is 144. And this gives you 12. So this would be minus 4 plus minus 6, as I just divide them by 2. So this can, the first answer can be minus 4 plus 6 or minus 4 minus 6. So minus 4 plus 6 is 2, and minus 4 minus 6 is minus 10. But we are not done yet, as this is the solution of a, not x, and the question is asking for the exact solutions of the x value. So what you do from here is you have to equate them together. So a is equals to 2 or a is equals to negative 10. And then from here you get x squared equals to 2, or x squared equals to negative 10, and you get x equals to positive negative square root 2, or x equals to positive negative square root of negative 10. And this doesn't exist, as that will be a complex number, so this answer would not matter at all. So this would be your final answer. Question 9. In this question, all lengths are in centimeters. A closed cylinder has base radius r, height h, and volume v. It is given that the total surface area of the cylinder is 600 pi, and that v, r, and h can vary. Part 1. Show that v equals to 300 pi r minus pi r cubed. So firstly, you have to read the question carefully, as it says all lengths are in centimeters, and it also says the total surface area of the cylinder is 600 pi. So using this information, the total surface area of the cylinder is 600 pi. How do you get the volume of a cylinder? How do you get this equation? Well, first of all, you have to know the surface area of a cylinder, and you have to know the equation of that. If you don't know, a surface area of a cylinder basically looks like this. So this is the two circles. So a cylinder normally looks like this. And now if you fold the cylinder out, it becomes like this. So this is the two circles. This is the two circles here. And this rectangle here is the part that's covering the cylinder. So the area of a circle, equation of the area of a circle is pi r squared. And since there's two of them, it becomes 2 pi r squared. Actually, we are actually getting the surface area of the cylinder. So surface area equals to 2 pi r squared. The height of the cylinder is the length of the rectangle. And the width of the rectangle is the circumference of the circle, which is 2 pi r h. 2 pi r, sorry. So the area of the rectangle becomes 2 pi r h, as you're multiplying these two. And then from here, you can equate this to 600 pi, as surface area is equals to 600 pi. And then from here, you can first remove all the pi's from all of them because they all contain pi. And then from here, you can just do 2r squared plus 2rh equals to 600. And now if you just simplify this, it becomes 2r squared plus rh equals to 300. And now you have to get this equation so that the h is the subject. Why, you may ask? Well, because if you see the question, it says show that v equals to 300 pi r minus pi r cubed. It does not contain any h values, as h is substituted inside the equation. So if you make h the subject by factorizing the equation, so that this becomes 300 over r, and h is it will be 300 over r minus r, or it can also be 300 minus r squared. So the normal equation for a volume of a cylinder would be the area of the circle times the height. And now you can see from this equation here, it says show that the volume is 300 pi r minus pi r cubed, and it does not contain any h values. So from here, you can just substitute the h value that you have found here. So since h equals to that, v equals to pi r squared 300 minus r squared over r. From here, you can simplify the r's, and you get 300 minus r squared, so So this becomes 300 pi r minus pi r cubed, which is your answer. So V equals to 300 pi r minus pi r cubed. And you have shown that. Part 2. Find the stationary value of V and determine its nature. So a stationary value of V, what does that mean? V equals to 300 pi r minus pi r cubed. This also means that whenever the value of r change, the volume will always change. So if r is 1, then the v will be a value, or if r is 2, then a v will be another value. So the stationary value of v is when dv dr, or if you differentiate this equation, the differentiation of this equation will equal to 0. As stationary value is when the value is fixed, it does not change at all. So it is when the gradient of the graph will be 0. So if you differentiate this equation here, it becomes 300 pi minus 3 pi r squared equals to 0. Now how I have done this is r to the power of 1. If you differentiate, when you differentiate, you have to move the power and times the whole value by the power of the unknown. So for example, 300 pi to the 300 pi r will become 300 pi as 1 times 300 pi is 300 pi. And after this you have to minus the power by 1. So that it becomes r to the power of 0, which is 1. Which is equals to 1. So for example, the pi r cubed here, if you differentiate this, you have to first multiply the known value by the power of the unknown, which is 3. So you have to do 3 times pi r, so you get 3 times pi r, and then you have to subtract 1 from the power of the unknown, so that it becomes 2. So it becomes 3 pi r squared. And then from here you can just solve the value of r. As it says, find the stationary value of v. So how do you do that? You can just first of all factorize this equation. 100 minus r squared equals to 0. And if you move this to the other side, it becomes 0 divided by 3 pi, which is 0. So 100 minus r squared equals to 0. So minus r squared equals to minus 100. So r squared equals to 100. And then r will equals to 10. As the square root of 100 is 10. Now negative 10 does not count, as there is no negative. There cannot be any negative length or negative radius in real life or anywhere. So the positive value is the real one. And then now you have to get the stationary value of v. So to get v, you have to use the equation, which is 300 pi r minus pi r cubed. If you substitute the r value inside, it becomes 300 pi times 10 minus pi times 10 cubed. So this becomes 3000 pi minus 10 cubed would be 3 zeros, 1000 pi. This becomes 2000 pi. So the v value will be 2000 pi cm cubed, as all lengths are in centimeters. And now you have to determine its nature. So to determine its nature, it means that you have to determine whether it is a positive value or a positive value or a negative value. So the stationary point is when the gradient is 0. The gradient of a graph is 0 when the graph is horizontally straight, just like that. So it is basically the peak point of the graph. So if you have to determine its nature, you have to differentiate the equation twice. So to differentiate this twice. So since you have already differentiated once here, you can just differentiate this equation once more. So to write this, you have to write d squared v dr squared equals to the 300 pi would be gone because there is no unknown, so it becomes minus 3 times 2 pi r to the power of 1, which is pi r, so it becomes minus 6 pi r. And then from here you have to substitute the r value that you've just got, which is 10. So if you sub 10 inside, it gives you minus 6 pi times 10, which will give you minus 60 pi. So since this is a negative value, it would be this one. As a negative value will have a maximum peak point, and a positive value will have a minimum point. So you can remember this by saying a sad smile has a maximum point and a happy face has a minimum point. Or you can say that a negative has a max and a positive has a minimum point. So since this is a negative point, so you have to write them down. Since d square y dx square is less than 0, as is negative 60 pi, it is a maximum point.